When we teach artificial intelligence to reason about the real world, we need a language more expressive than simple zeros and ones. Welcome to first-order logic, or FOL. Think of FOL as the foundational grammar of symbolic AI. While basic propositional logic only deals with simple, rigid facts, first-order logic lets AI break the world down into objects, their properties, and how they relate to one another. Today, we will explore its building blocks. Let's start with constants. In the grammar of first-order logic, constants are the proper nouns. They represent specific, distinct objects in our domain of discourse. If we are building an AI to manage a smart home, our constants might be things like Alice, kitchen, or thermostat. Every constant points to exactly one specific thing in the real world. They anchor our logical sentences to reality, giving the AI a concrete vocabulary of items to reason about. But an AI cannot just memorize every specific object, it needs to generalize. This is where variables come in. Think of variables as pronouns like "ori" that can stand in for any object in our universe. Together, constants and variables form what we call terms. A term is simply any logical expression that refers to an object. By using variables, our AI can learn rules that apply universally, rather than learning a new rule for every single constant. Now that we have objects, we need to describe them. Enter predicates. Predicates are the adjectives and verbs of our AI grammar. They define properties of objects or relationships between them. Crucially, a predicate always evaluates to either true or false. For example, is open door tests a property and returns true if the door is open. A predicate can also relate multiple objects, like friends, Alice, Bob. By combining terms with predicates, we create atomic sentences, the basic facts of our knowledge base. What if we want to refer to an object that depends on another object, but we don't want to invent a new constant for it? We use functions. Functions act like complex nouns. Unlike predicates, which return true or false, a function returns an entirely new object. For example, mother of Alice evaluates to the person who is Alice's mother. It maps one object to another. This is incredibly powerful, as it allows the AI to reference infinitely many objects using a small set of relationships. With constants, variables, predicates, and functions, we can construct complex logical sentences. But the true magic happens when we add quantifiers. The for-all quantifier lets us state universal rules, like every human is mortal. The exists quantifier lets us express that at least one object satisfies a condition, like there exists a key that opens this lock. By combining our grammar elements with these quantifiers, our AI can infer entirely new facts from existing data. First-order logic provides a rigorous, unambiguous grammar for artificial intelligence. Constants give us objects. Predicates describe their relationships. Functions map them to new entities. While modern AI often relies heavily on neural networks and probabilities, symbolic logic remains the gold standard for structured reasoning, knowledge graphs, and verifiable truth. Understanding this grammar is your first step toward building intelligent systems that truly comprehend the world.